Welcome, LifeBlood. This is George G, and the time is right. Welcome to today's guest, strong, powerful Dr. Charles Brenner. Dr. Charles, are you ready to do this?
I am ready.
All right, let's go. Dr. Charles is a PhD. He's the chief scientific advisor with ChromaDex. It's a global bioscience company dedicated to healthy aging, delivering niagen, the sole active ingredient. Dr. Charles, tell us a little bit about your personal life, some more about your work, why you do what you do.
Okay, I think I can do that. Let's see, I'm a 61-year-old guy. I live in Pasadena, California. I run a research group and a department at City of Hope National Medical Center in Duarte, California. Our department is called the Department of Diabetes and Cancer Metabolism. And essentially what I do every day, 24/7, is I work on the central catalyst of metabolism, nicotinamide adenine dinucleotide, NAD. So it's the wiring of every cell in your body. And we discover pathways of synthesizing NAD. We discover diseases and conditions in which the NAD system is disturbed, and we try to figure out ways to improve human health by modulating NAD.
Love it. And you enjoy that work.
I sure do, yes.
So I'm fascinated and I'm super grateful that there are people like you who do the kind of work that you do. You discovered, tell me what it is you discovered, and
Yeah.
I'm curious, were you looking for it? How does the discovery process happen?
Yeah. So I was minding my own business, working on an enzyme that forms NAD, the central catalyst of metabolism. I was doing that work in yeast. And it occurred to me that when I was trying to figure out how the enzyme worked, that I could learn some new things about how NAD is made. And we suggested at that time, back in around 2003, 4, so about 20 years ago, that there might be another biosynthetic pathway to make NAD, another fundamental building block that could be turned into NAD. And in so doing, we discovered the vitamin activity of nicotinamide riboside. And there were two known vitamin precursors of NAD at that time, and we discovered a third vitamin precursor. And the genes that are used to convert NR into NAD coenzymes. And we haven't looked back since. We found a lot of things that were not well understood about this fundamental catalyst of metabolism.
So you discover a third precursor. What does that mean in a more simplified version?
Right. So back in 1938, there was a scientist named Conrad Elvehjem that discovered that nicotinamide and nicotinic acid can prevent pellagra. And then we later understood that both of those molecules are small molecules, we call them vitamins, that can get into cells, and that cells can use either nicotinic acid or nicotinamide to make NAD. Vitamins depend upon genes and enzymes to convert these very small molecules into coenzymes. And we discovered that NR, nicotinamide riboside, is yet another vitamin precursor of NAD. And the interesting thing about NR is that when the NAD system comes under attack, for example, in heart failure, neurodegeneration, when DNA is damaged and has to be repaired, the genes that I discovered, the nicotinamide riboside kinase genes, get upregulated. And so it looks as though damaged cells and cells that need NAD to restore their resilience depend on the NR pathway to regenerate NAD. So that's part of the value of nicotinamide riboside, and part of the reason that it's been commercialized into a supplement, and it's now being tested as a drug as well.
So you said that it's able to get into the cell, and so that suggests to me that that's not an easy thing for just because I introduce something into my body doesn't mean it can actually get into the cell.
Well, right. So when, NAD is a central catalyst of metabolism in all of your cells, George, and it's also the central catalyst of metabolism in all of the cells of an avocado or a cow or whatever it is that you choose to have for lunch. When we eat whole foods with a small W and a small f, I'm not making any grocery store endorsements. When we eat unprocessed foodstuffs, there's macronutrients in the food, protein, fat, and carbohydrate, and there's also micronutrients in the food. And so the NAD that's in plant and animal products breaks down into precursors, and then those precursors go into cells in order to regenerate NAD. So you might say to me, gee, if NAD is the central catalyst of metabolism, why don't I take NAD as a supplement? And you could, but NAD would break down into NR. NR is the largest piece of NAD that can get into cells. There are people that have tried to popularize NMN as a NAD boosting molecule, but NMN actually has to be broken down to NR before it can get into cells. So NR is the biggest piece of NAD that can get into cells, and that's part of the value proposition of NR.
Got it. All right. So we want it in our cells.
We need it. Yes. And although it's a catalyst, which means, a little can go a long way, the NAD coenzymes come under attack in conditions of metabolic stress. So, for example, when you drink alcohol, the metabolism of alcohol converts NAD plus to NADH. That accumulation of NADH can lead to things like alcoholic fatty liver and reductive stress. When we overfeed a mouse in order to give it obesity, type 2 diabetes, and those types of metabolic diseases, we see an attack on the NAD system. When DNA is damaged, NAD is used to repair the damage, and NAD system comes under attack. And then very commonly in things like infection and inflammation, if you work around people, I like to say if you enter rooms that have 20, 25 people in them 5 days a week, you're likely to be re-exposed to coronaviruses every week. The susceptibility to viruses, not only coronaviruses, but other respiratory viruses, depends in part on the NAD system. NAD system comes under attack when we're activating our innate immune system to fight off these viruses. And so the thinking is that a higher NAD status protects you from many of the conditions of metabolic stress that you encounter in your life.
Got it. So our cells need it when we are overweight, dealing with viruses or disease. It puts a strain on the system. So the more we can introduce in a way that's going to actually work, the stronger we're going to make our cells.
Right. So you're boosting your NAD status in order to enhance your resiliency and your resistance to metabolic stresses. Things that we take for granted and more or less need, like we don't technically need sunlight, but the sun is with sunscreen is good for us. but sunlight will damage DNA. Oxygen is essential for life, but oxygen leads to reactive oxygen species that actually churn one of the 4 NAD coenzymes, NADPH. And so the micronutrient component of our diet can be enhanced by an NR supplement. And as you said, I'm the chief scientific advisor of ChromaDex, which licensed the technology from Dartmouth College for uses of NR, and produced, a supplement that has been safety tested. It's a new dietary ingredient, can't be taken off the market. And in addition to being available as a dietary ingredient, it's also being tested in these disease models in which NAD comes strikingly under attack.
I think it's exciting, and I think I'm tracking. So it's great for our immune system, and it has healthy aging components, or it's really one and the same.
Yeah, so aging is a series of challenges. I mean, I like to think that aging is a privilege. I don't use the word anti-aging. It doesn't really make sense to me. It's sort of a category of a lot of stuff that's fake. And nicotinamide riboside is a science-based product. It's a vitamin precursor of NAD. So we think that there's a role for NR in healthy aging and resiliency and enhancing repair capacity. It's widely reported that NAD declines in aging. Whether that is a summation of all of the different episodic attacks on NAD or part of the aging program is not entirely understood. But we see in many different models of aging and disease in animal systems that NAD comes under attack and that NR is protective. And now there's human clinical trials in a variety of disease and conditions in which NR is producing positive results. So NR increases cerebral blood flow in Parkinson's. That was such a promising trial that when it concluded, the authorities in Norway wanted to make sure that everybody that was on placebo and everybody that was on NR had access to NR in order to better manage their condition. There's been indications of positive results in body composition, in lowering inflammatory markers, potentially in reducing fatty liver, potentially improving blood pressure management in people that have moderately elevated blood pressure. So it's a very exciting molecule that is getting a lot of traction in the research world.
Yeah, it sounds like it. I don't know that I've ever heard aging is a privilege, 4 words strung together like that, but it certainly makes sense.
I strongly believe that way. First of all, there's a developmental / programmed component of aging. If we've learned anything from model systems, the most powerful mutations in mice that give you very long-lived animals are in growth hormone signaling. So they're shrimpy little dwarf mice that cannot reach a normal size, and they don't, they're sexually incapable. So they don't go through a proper puberty, and they can't reproduce, and they're tiny, and they can't fend for themselves. Those are the extremely long-lived mice. And so we know that there's the genetics of aging is very difficult, if not impossible, to separate from the genetics of development. So we know that part of aging is programmed, that laboratory mice live 2 or 3 years, And naked mole rats, which have basically the same size and body plans, live 10 times as long.
Hmm.
Why? Because naked mole rats evolved to maintain their maturity and their power for 10 times as long as mice. Humans, we get to live to 70 or 80 or 90 or 100 years, occasionally up to 120. So we have a great gene set, and what we are trying to do in healthy aging is achieve our, genetically encoded longevity, and to kind of square the curve, which means to not experience long, parts of our life in which we are not capable of taking care of ourselves. So the idea of aging better is to try to maintain fitness and muscle mass, eat well, be socially connected, and then try to do whatever you can in order to maintain resiliency and repair capacity. And we think that NR is part of that healthy lifestyle.
That makes a lot of sense. In your work, and I suppose in scientific research in general, I'm curious, do you run the risk of getting frustrated because you don't find breakthroughs, or are you constantly finding new clues or different pathways to kind of explore? So I guess, do you run the risk of getting frustrated and wanting to quit ever? How does that work?
Well, the thing is, you can't be too attached to your hypotheses. I find the people, in biology that are most attached to their hypotheses, and they use like title case a lot, like I'm testing the information theory of aging or whatever. Those are the people that they're just sort of attached to a result coming out a
Hmm.
particular way. If you really are trying to discover objective truth, then you set out to disprove your own hypotheses. And you have to have a, testable model that could be falsifiable. And so when we look at things that way, we are not really frustrated so much as peeling the onion and trying to discover what is underneath. So biology is really complicated. I like to tell people that rule one of biology is that there's no violation of anything in chemistry or physics. And rule two is that everything is encoded and subject to selection for fitness, and encoded in DNA. And but beyond those two rules, almost anything goes in biology. And so you have to keep an open mind, and you have to be willing to have your pet ideas disproven. And so we do set out in our laboratory to test our hypotheses, and it's only by doing so that we can find things that really hold up well.
If we could all just adopt that mindset, doctor.
It's important, right? To not become tribal and too attached to pet ideas. But what we've learned is that there's a terrific book that I reviewed by a professor at University of Alabama at Birmingham named Stephen Austad. And Stephen Austad has pointed out that bigger animals generally live longer than smaller animals. But then you can kind of correct it. You can see what is a really good ager for its size versus not so good an ager for its size. So human beings are not the biggest primates, right? Gorillas are way bigger than humans, but humans live longer. Humans are better agers than chimpanzees, or better agers than gorillas, just like naked mole rats are better agers than mice. So it turns out that we can learn things from creatures like human beings that age really well. There's certain things that we can learn from mice, but certain things that we can't extrapolate from mice. And even though I started out, I told you 20 years ago, I was working on yeast, and when we discovered the nicotinamide riboside kinase pathway and the vitamin activity of NR, we could extend lifespan in yeast. 2007, with nicotinamide riboside, but I never claimed that NR is going to be a life-extending compound in human beings on the basis of a yeast experiment. That would be more or less ridiculous to suggest that yeast anticipates the cause of aging in animals, and because yeast, existed before there were any animals. So, we try to keep an open mind. We try to learn from nature and do experiments that will illuminate the way things work. We also don't get out ahead of our skis. So we know very confidently that NR is safe. We know that it has profound value in animal models, and it has a lot of promise in human disease and conditions. And that's why we're so excited by it.
Love it. Well, Dr. Brenner, thank you so much for coming on. Where can people learn more about you, and how can we take advantage of NR and NAD?
Sure. Well, if people have questions for me, they can find me on Twitter at Charles M. Brenner. They can look up our laboratory at brennerlab.net. Laboratory, as I said, is at City of Hope in California. And truniagen is the patented, safety tested nicotinamide riboside, and they can find that at truniagen.com. So thanks so much.
Excellent. Well, if you enjoyed this as much as I did, show Dr. Brenner your appreciation and share today's show with a friend who also appreciates good ideas. Find Charles on Twitter under Charles M. Brenner. It's CHARLES, letter M, BRENNER. Find him also at brennerlabs.net.
Brennerlab.net.
Brennerlab.net. And then truniagen.com. And I'll link all those in the notes of the show.
Great. Thanks.
Thanks again, Dr. Brenner.
My pleasure. Thank you.
And until next time, remember, do your part by doing your best.